Hi, this is Big Tuition, and this is a quick review about the chapter of functions. So to begin with, we'll need to define what exactly is a function. I'm sure you have encountered functions before in the case of like drawing graphs and things like that. A function is like a relation between two variables. But a proper definition would be that it's a relation that maps each input to exactly one output. This part is important, the exactly one output, okay? You can also think of it as how varying one quantity affect another quantity. So each input, right, they are all numbers within a domain, what is called a domain. Domain is just all the possible inputs, and range is all the possible output. And to denote a function properly, what happens is the relation is denoted as a letter, usually f, and there's a bracket that tells you what is the input that you take. So in this case, usually it's denoted as x, but sometimes it can also be other letters like x is y, u, v, etc. Okay, so one example of a simple function would be, let's say you have homework to do. So there's homework, and homework have a number of question x, number of questions, and you want to know how much it take, how long it take. So maybe you know how long you need for one question, and then you can make a function that takes in x and gives us time t of how long you need to take to do your homework. Okay, so functions can be one-to-one or many-to-one. Why is it always to one? Is because we need the function to have exactly one output. It cannot be one-to-many. It kind of makes sense, right? Because if you have a number of homework, like in the example, and your function tell you two different outcome. One is 3 hours, one is 2 days. Then it doesn't really make sense, right? You know that if you do your homework, you should be able to finish it in a rough amount of time. So that's why one-to-many is not mathematically a function, but it is still a kind of relation, a mathematical relation. It's just not a function. How it looks like for functions mapping between domain and range is shown in these diagrams. So the domain is on the left and the range is on the right. For one-to-one functions, each input can map only to one output, to one and only one output, whereas for many-to-one functions, some inputs can correspond to more than one output. Like in the case of these arrows, you see that both 1 and -1 can correspond to 2. Okay, so simple example will be these two functions here. I highly recommend you to just draw it out, and you will see why they are, one is one-to-one and one is many-to-one. It also help you with your graphing practice, sketching graphs. One thing to note is that one-to-one function is strictly increasing or strictly decreasing. This is because if you have a graph that is not strictly increasing, that means there's a turning point, right? And once there's some kind of turning point, you notice that there's two x values that give you the same y value. And if that's the case, then it's not a one-to-one anymore. It's a one-to-many. No, sorry, many-to-one. Okay? It's a many-to-one. For many-to-one functions, for example, an x-square graph, it is actually possible for us to restrict the domain such that it becomes a one-to-one function. So in this case, we can restrict the domain such that it is only to the right side of the graph. So let's say we restrict the domain to be only this direction. Then you see that the blue graph becomes a one-to-one graph. This is important when we are talking about inverse, which is the next section of this chapter. So for inverse function, it is the reverse relationship where output can be mapped to its input. So using back this example of how long you need to do your homework, copy. Okay, the inverse function will be given the amount of time, how many questions you can do, maybe. Or maybe your friend tell you how long he took to do the homework, but you don't know how many questions there are, and you can infer how many questions there are in the homework. Okay? Yeah. So this can be useful in certain situations, very applicable to reversing the answer to find what's the original input. But because the inverse function is also a function, it needs to be one-to-one or many-to-one as well. But of course, if the inverse function is many-to-one, that means the input, the original function is one-to-many, which would not be a function. which means that the only possibility for inverse function to exist is when the original function is 1 to 1. Okay? When we have an inverse function, the input becomes the output and the output becomes the input. So the domain also flips. Okay? If it sounds confusing, basically just think of it as you are reversing all the arrows here. So your range now is the domain, and your domain is now the range. Okay? So to find a inverse point on a many-to-one function, such as the quadratic graph, like this, we must first change it to a one-to-one function by restricting the domain, so that there is an inverse. If you do not restrict the domain, it's a many-to-one. You try and inverse it, you become a one-to-many, it's no longer a function. Okay? So next is there can be composite functions that is composed of multiple functions. So in this case, the output of one function is used as the input for another function. So in the diagram, it will look like this, where this is the original domain. This is the domain of f, the range giving us the range of f, which serves as the domain of g. And finally, it gives us the output. Okay? So one example of this in more practical sense might be, you can think of it as like x, maybe like an example is distance that you want to drive. Maybe you are going on a holiday trip. Then y, it will be the amount of fuel you need to drive that amount of distance. And z can be the cost of fuel. Okay, of course the relationship between distance to drive, amount of fuel, and cost of fuel is quite linear, it's quite straightforward, you just multiply. But functions work basically the same way. You take the input, so first you have an input x, and you get the output fx. Then you can take the fx and you input into a function gx. You input into a function g. G is basically whatever you put as input into g, in this case, will give you the cube of the whatever you put in. So now we put in the entire function, so it looks like this. You cube the whole function, right? And this would give us a final outcome of x plus 2, whole thing cubed. In a composite function, the rightmost or also the innermost function is applied to the input x first. Okay? So for the composite function to exist, the range of the first function must be within the domain, the total possible domain of the second function. If your range exceeds the total domain, that means some of the input will become invalid output, undefined outputs, and that would not be a proper function. So last point to note is the inverse composite function should actually give the same answers as each other, because there are two ways you can inverse it. You can first apply the inverse and then you apply the function, or you can apply the function first, then you apply the inverse. Both of them should give you back the original input that you put. But note that they are technically different functions because their domains are not the same. This nuance is not super common to be tested, but this is just something to keep in the back of your mind as you do your questions, if there is a f inverse. Okay? So with that, we basically covered the concepts in functions. I hope you managed to revise this, and happy studying.